board, right? And you came up with this. Okay? So what you're going to do is, we're not going to use the circle one. We're going to use the grid pattern one. And you can change the size of the grid. So for the activity, you're going to start with a 7 by 7, but you're going to be able to change it throughout. Okay? So, over here are your rubber bands. And what you can do is, so if you choose a pink rubber band, oops.
Wait, how do you get it to be
Go
on the
back.
grid?
Okay. So, you take your rubber band and you drag it over. And then you can grab your rubber band and you can make it whatever size you want. Okay? And then you can add a different colored rubber band and make that whatever you want. If you want to remove one of your rubber bands, you just click and get rid of it. Okay? So if I wanted to get rid of that, maybe I wanted a green one. Okay? Make sense? So I'm going to give you a couple minutes to just play with that. And just get a feel for the rubber bands and how that works. Okay? Yeah. I'm going to have you erase it for the activity when we get started. Specifically squares. Hands off your Chromebooks, please. Okay. So we're not looking at rectangles or triangles. So what's special about squares? So that we are specifically looking at squares. Why? What's special about them? Riley?
All the sides.
All the sides are the same length. Anything else? Amy?
There are 4 sides.
There are 4 sides. So that makes it a quadrilateral. Okay? So we're looking at quadrilaterals with 4 sides that all have equal sides. Cornelia?
360 degrees.
Ooh, very good. The degrees inside of it. So thinking about what we did last week, the degrees inside of it are 360 total. Because there are 4 90-degree angles. So what's special about a square is that it has 4 90-degree angles and it has all equal sides. Okay? So you're going to need your Chromebooks and a pencil for what we're going to do. So go ahead and reset these so that you have no rubber bands on it, and so that it is a 7 by 7 grid. Okay? So it's blank and it's got 7 by 7. Okay? Alright. So, really quick, let's just make sure we all agree on some terminology. So I'm going to just use a rubber band to show you this. From peg to peg is 1 unit. This right here is 1 unit. This is, okay, we'll try this.
Yeah, you're not.
What's it doing? Why is it broken?
It's a broken rubber band.
Okay. Anyways, 4, 5, 6. Okay? Are we clear on the vocabulary?
Yes.
Area, perimeter, and unit. Okay? Riley.
I'm still confused on area.
So area is the amount of space inside of a figure. So all of this area in here, that's the area of this rectangle.
And the units are the same for like inside and outside.
Yeah, so to measure the area, so the area is what fills up this whole space. To measure this area, I'm going to count the units. So this little square right here is 1 square unit. This other little square right here is the 2nd square unit. Okay? So if I made it bigger, I would count all these square units. 1, 2, 3, 4, 5, 6.
And then, how would you find out the side length by having the area?
Because this would be the area, all of it inside, you would build it. So if it asked me for a figure with an area of 6 square units, I would make a figure with 6 square units, and then I'd count the side lengths. This is the side length, and this is the side length. Okay?
Oh.
Okay. Amy.
Does it always work if you just times like 3 times 4 divided by 2? Or like, because for the first one, it was, the first one was like that? Or does not always work?
It won't let me make it smaller. So for the first one, it looked like this. Right? So the side lengths are 2 and 1. Okay? Alright. So, good questions. Alright, so let's look at this. You should all have this in front of you, right? Okay? So the first thing that you're going to do is you're going to work on this top table. We need one more. So, the top table is the side lengths. So we'll do the first one together. So side length. So a side length of 5 units. So I'm going to make my side length 5 units. 1, 2, 3, 4. Not long enough. 5. Whoops. This thing doesn't like me. Holy cow. Start over. 1, 2, 3, 4, 5. It's going to have side lengths because it's a square. All of them will be 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And then, there we go. Is that a square? Okay. So, it has side lengths of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The area. So how many square units are inside of this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. If you guys know how area works, you can probably do that mentally without counting. But feel free to count. Okay? What would the perimeter of that be? Claire? 20. Because it's 5, 5, 5, and 5, right? 5, 5, 5, 5. Okay? So you fill that out. And then you would build the next one with 8 units for its side length.
Do you build it over it?
You can build it, I wouldn't. I would just delete it, erase it, and then start a new one.
But it's a 7 by 7, so it wouldn't be able to fit. You can make.
You can increase your,
Start again.
yeah, you click start again. Click start again, and then you can change the size of your grid, okay, for what you need. Got it? So work through this top table. The goal at the end is to figure out X and Y. What can you do if you don't know the number of sides? What would the rule be is what you're looking for at the bottom. Okay? So you're going to make some observations, you're going to come to some conclusions, and then hopefully come up with a rule that will work. Okay? Go. Feel free to discuss with your shoulder partners.
Attention Granite Mountain, just wanted to let you know that the drama club has been canceled for today. The drama club for today has been canceled. If you need to make arrangements to be picked up, please come to the office.
That's perimeter, because 20 is the distance all the way around the outside. Area is the amount of space inside. Yeah. The area inside. 40. That's just unit square. That's how you label area. That's how you label area. It's because I'm magical, and when I stand next to you, things work. You're welcome. Magic us. This is just the area that we're trying to build a square. 49 units in there. It does, that's the label. Ladies and gentlemen, you're getting a little thrown off with the units squared on the third one. Units squared is just a label for area. It's just saying that it means a square unit. Okay? It's not telling you to multiply 49 times 49. It's just that there's 49 square units inside that square. You're making, that's any figure. No, like when you do n minus 2 times 180, it's for any size figure. So that's saying for any size square, what would you do? Finish the rest of it first. You have to come to some conclusions and make some observations. Squares only, no rectangles. You are allowed to have discussions with your shoulder partners.
Did you get 64 for area? Number 2.
Yeah.
Okay. You don't need to change this to this. Like what you're doing, you don't need to do that.
Doing this because you want.
You can make them on here. So you want something that's already inside it. I mean, you did it right.
How do I edit this?
So, you can just leave this information down. There, you did it right. It's just, you don't need to change the pegs.
Okay.
Good. How's it going?
Good.
I'm going to set the timer for 5 minutes. Let's try to have this part of the table done. Now you're making observations about all this information and what could it be if it were just X. Two on each side. Well, if it's 2, 2, 2, 2. Two here, 2 here. Yeah, the side length is 2. 1, 2. No, the perimeter all the way around. Okay. First of all, you don't need to change this. This can stay this. So when you build it, you're going to build it with a side length of 2. So there's your side length around 2. 1, 2, 3, 4. It has 4 inside. Okay? So now what's the perimeter of that? Okay, count all the way around.
Is this times 4?
1. No, not peg. Units.
Times 3 times
Multiply by 4 is 3.
what times 4 is 12? This would be 1. So I guess we're doing 24 times 3.
Wait.
I like it. Yeah.
Since there's 4 corners by this square, we just make it that one 5. This one was 5 squares, 20 squares. Then you get 24 is that. The one with the plate.
Multiply what by 5?
No.
The
No, not 24, 12.
The side length is 5.
12, right.
Yeah.
So you multiply by 5 by?
4 because there's
4 sides.
yeah. And so I won't believe 12.
So for this, you need to do, basically you're writing a rule. So if I don't know the number of sides, for any square, what would I do?
3.
How many sides?
You just explained it to me.
4.
So how do you write that as a formula?
3.
So then
Oh, side. No, yeah, side length is 3.
So think about it. You just said it to me, everything.
Yeah, that was right. I mean, 40.
Yeah.
Keep going. Is this the shape that it would make this square?
Square? It needs to be a square.
Last one.
So you have to find a square.
Wait,
It
this
has
one
to
is
be a
this one?
square
This one
that has 49 units inside the middle.
How do you do X units?
Wait. I'm trying to figure out something. Are we gonna go over this?
Start building them. Start building squares. Build squares until they have 49 square units inside. And Emma and Kenzie. So, let's look at this. There we go. Okay. Zoom. Okay. Okay. We figured this out, right? So the first one we did together, 5 units. The area, if it was 5 by 5, the area inside was 25. The perimeter, and this is something that was confusing you guys. Units squared, that's just a label. That's saying that there's 25 square units inside that figure. Okay? So around the outside, there was 20 units around the outside. Right? Okay. So, on the 8 units, it was 8 by 8. So how many were inside the figure? Indy. There were 64 inside. The label is units squared. Square unit. It's just a label. It tells me that I'm talking about the amount of space inside that figure. Okay? So if it's 8 and 8 and 8 and 8, what's the total distance around the outside? Riley?
32.
32. Okay. Emma? Okay, so you were struggling with number 49, or with the third one, and you figured out that 49 boxes in the inside would be how many on each side? 7.
Because I noticed that 8 goes into 64 at 10, so what goes
Right.
into 49?
Right. You're basically doubling it, right? Or not doubling it, but squaring it. Okay. So, 7. If it's 7 7 and 7. Aw, Tommy and Emma D. Okay. All right. So if it's 7, 7, 7, and 7. What?
28.
28. Okay, if there's 4 on the inside. Chloe,
6. Then
what was the side length? 2. There's 2 on this side and 2 on this side. So 2 is the length of the sides. Why don't I list the side lengths twice? Because it's 2 and 2. Why am I not listing it twice? Ariane? Because it's a square. The sides are going to be the same. Okay? So, if it's 2, 2, 2, and 2, what's the distance all the way around? Ryland, what's the distance all the way around? 2, 2, 2, and 2.
8.
8. Good. We spent a while talking about that one, Ryland. That's why I asked. All right. Now, the distance all the way around is 12. Some number, and some number, and some number, and some number is 12 altogether. Casey. So, you're telling me that 3, 3, 3, and 3 is 12?
Yep.
So what would be the inside then? If it's 3 and 3, what would be everything inside? Carson.
9.
9. Okay. So 24. Some number, and some number, and some number, and some number. All the way around is 24. Emma? 6, 6, 6, and 6 adds up to 24. Do you agree with Emma?
Yes.
I can draw a picture. Because some of you are looking at me like I'm from Mars. Emma is saying that 6, 6, 6, and 6 is 24. Okay.
Oh.
So the side length is 6. So if it's 6 and 6, how many are inside this thing? What's in here?
36.
36.
Oh, I get it.
Getting the hang of it? Okay. Now, this also threw you guys for a loop. You're like, what do I do with X? So this is where you look for the pattern. What am I doing here, and here, and here, and here, and here, and here? What's the pattern? Sam.
X times X.
X times X? Is there another way you could say that?
X to the second power.
X to the second power. Okay? Either one of those would work. So, what are you doing from here to here? These numbers, to find the perimeter. What's that pattern? Brianna. Multiply what by 4? S squared, S times 4. Or X times 4. Okay, so you figured that out on your own. Now, what about this one? How do these relate? Or these? What do you notice there? That one's a little trickier. Chloe, what did you notice?
Well, what you do is y divided by y. Like, because you see how,
Can anybody think of a perfect square that isn't on here? Emma. 16 units would be a perfect square. So what would be the square root of 16? 4. Okay, good. Claire.
100 units.
100 units. What would the square root of 100 be? What? It would be 10. Yes, good. Okay. So,
What's great?
That was 1,000,000.
so the square root of y would give you the side length.
I always wanted to.
Actually, let's put side length. Okay. So, once I know the side length, how would you find the perimeter? Aria? Add up all the sides or multiply it by 4. So this would be 4 times the square root of y. So in order to figure out side lengths or the perimeter, you would multiply that by 4. Okay. All right. So, what time is it? Okay. So, here's what I want you to do. This bottom part. I want you to, you're going to use the geoboards on your Chromebooks, and you can come up with any square you want. Any size square. Any side lengths. So, you're going to pick one. Like, let's use Blair's, for example. The area was 100. 100 square units. Yeah. Write that down. This is your example. So, on your Chromebook, you would find which one would be an area of 100 square units.
It doesn't let you do 100.
It doesn't let you go up to 10.
It's with 12.
Well, 10 by 10, a 10 by 10 is 100. So, the side lengths on an area of 100 would be 10. So, what's the square root of the area? So what I want you to do for this is write the square root of the area would be 10. Okay? So, just use your Chromebooks to investigate and look at 5 more. I want you to build 5 more. Okay? Just build 5 more squares, any size you want, and fill out 5 more sections of that table. Okay? No. Go. Just build any 5. Did you try shutting it down?
I started restarting my days.
And then try logging back in. Just, it has to be a square. That's not a square. They have to be squares, ladies and gentlemen. Yes. Yes. Do 5 more squares. Yeah. Up there. Do any 5. Area. I want you to put them on your geoboard. Thanks, Taylor. Are you okay?
A square has even sides, 4 4. I know that, but you can do that.
Does that make a perfect square? It has to be a perfect square, or it's not going to work. Any number. So this number has to be the same as this one.
5, 6,
Does 1 make a perfect square? 1 side length?
Is it equal to 12? Because I'm doing
No, that's perimeter. Side length is just the length of one side.
You need to build one that is an area of one.
So will side length and square root of the area be the same?
What?
Will the side length and square root of the area be the same?
Yes. Okay. So, let's have a few people share. What'd you come up with? Emma B.
So I did the side length was 11,
So what was your area?
132 square units,
132.
and then for the square root of the area, it'd be the square root of 132 equals 11.
But isn't 11 times 11 121?
Yeah, listen.
Yeah, 1 times 11.
Okay. So that's okay though. So this would be 121. So the side length would be 11. So the square root of 121 would be 11. Okay. Chloe.
I made 9 for the side length,
Okay.
and then I got 81 for the area,
Okay.
and that'd be 36 for the square root.
No. So the square root of 81 is 9. It's not asking for perimeter. Perimeter was something else. Okay? It's just asking for the square root of the area. How'd that work out?
It's 0 on everything.
Right? There's no square. Right? Okay. Indy.
After the area,
144 is for the area. Okay. Good. Okay. Kenzie.
area is 36,
36.
and the side length is 6,
Okay.
and the square root of 36 is 6.
Okay. Amy.
I just did one without the geo. I did one extra, and I did 13. I got 169.
169. Nice. The square root of 169 is 13. Personally, I would suggest that you memorize like between 1 and 15. Because up to 12 it's really easy. You already know that 12 times 12 is 144. And so you only have a few more that you need to memorize. But that'll help you significantly to just have them memorized real quick. Okay? Someone have one that's not up here. Tommy, hold on. I'm sure you have a good one. I'll get to in a second.
For area units, I got 16.
Okay, 16.
And then for the side length, I got 4.
Okay.
And then for the square root of the area, I got the 16 of the sign over it, and then equals 4.
Square root of 16 is 4. Good. Okay. Emma D.
For the area in units, I got 4,
Okay.
and then 2,
2 for the side length.
and then square root of 16 4 equals 2.
Good. Carson.
I did this one like on paper, and the area is 225,
Ooh, okay.
and then the side length is 15,
Okay.
and then the square root of 225 is 15.
Good one. Okay. Blair.
So the area in units is 1 million.
Woo!
The side length is 100,000. And then the square root of the area is 1,010,000.
Okay. So the square root of 1 million, you're saying is
100,000.
okay. But when I'm multiplying, it needs to be, so it would be, you're saying 100,000, right? So I'm multiplying those together. So that means I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros in my answer. But I need 6 zeros. So it would be 1,000 times 1,000. Wouldn't that give you 1 million? Someone check it.
Yeah.
So that would be 1,000. Good one, Claire. It's 1,000. 1,000 times 1,000 is 1 million. Cornelia.
I got 9 as the area.
So go ahead and turn it over. So what I'd like you to do is I would like you to answer these 3 questions using the information that you learned on the front. If you know the side length of a square, how can you find its area without a geoboard? And then if you know the area of a square, how could you find the side length without a geoboard? And then what is the relationship between side length of a square and the square root of its area? So I want you to answer those 3 questions using mathematical evidence, using the information that you learned or the conclusions that you came to on the front of this. What evidence can you provide to answer those questions? What's the date today?
17.
15, 16, 17. Does someone want to share their response to the first one? If you know the side length of a square, how can you find its area without a geoboard? Emma D.
If you do the side length times itself, you get the area. So if the side length was 5, you do 5 times 5.
Okay. All right, number 6. What is the relationship between the side length of a square and the square root of its area? Really quick, what I'd like you to do is A's, I want you to go first. A's, I'd like you to share your response to that question with your shoulder partner. And then when A's are done, B's, I want you to share your response with your shoulder partner. You guys will go on a 3. Ready, set, go. Actually, quick.
Side length and the square root. They're like the same thing. Like the
What is the relationship between the side length of a square and the square root?
The side length is the square root of the area.
Side length is the square root. It's actually the side length and the square root are both the same number. The square root is the area divided
Right,
the
so if
area.
you're square rooting the area, what would the answer
The
be?
area units divided by
square rooting? Well, when you're square rooting, you're trying to find what two numbers multiply together to get that bigger number. Think about it. Take out the word dividing. Megan, what did your shoulder partner say?
She said, they're 1 plus 6 the square root of the area.
Nice. I like that. Good explanation. Because the square root of the area is the side length. Okay. All right. Make sure your name is on this. Stack it in the center. Okay. It is not a lot. I noticed that Tanner just decided to get started on his homework, and he's already halfway done with the front. Okay? But listen, as far as the front is concerned, you only have to do this top square root section. Don't do the bottom squared section. Haha. That's what you get for starting before I give you directions. Okay?
Tammy's already done.
Okay. Now, the inside is really just as easy as the front, except it's in word problem format. And it seems like a whole lot of questions, but there's only 15. Okay? Questions. You will do all the word problems, and then just that front half.